Hey everyone, welcome back. Today, we're going to make your websites lightning fast, and not in some rewrite everything from scratch kind of way. Nope, we're doing it the lazy developer way. Small, surgical improvements that give you huge performance boosts. By the end of this video, your Lighthouse score will go up, your bundle size will shrink, and your site will feel buttery smooth. All right, let's jump right in.
Let's start with the low-hanging fruit, images. Because honestly, if your site feels slow, it's probably your images. Here's the thing, JPEG and PNG are old school. If you're still shipping those, you're basically sending a brick over the internet. Switch to WebP. It's supported by every modern browser and gives you up to 80% smaller file sizes with the same quality. Let me show you. Classic IMG tag. It works, but it's outdated. Modern browsers can do much better.
Meet the picture element, a tiny change in your HTML that gives you massive performance gains. Here's how it works. The picture tag is a container that lets the browser choose the best version of an image based on what it supports. Inside, you list your sources. The browser goes top to bottom. If it understands AVIF, great, it loads that. If not, it tries WebP. And if it doesn't support any of them, it falls back to the regular JPEG inside the image tag. No JavaScript, no hacks. Pure HTML magic. Same image, same quality, but WebP is up to 80% smaller than PNG or JPEG. That means faster page loads, happier users, and better SEO.
That's it. One tiny HTML change, and your website instantly feels lighter and faster. Picture plus WebP, the easiest performance win you'll ever get.
Even if you're using WebP, it's worth compressing your images before uploading them. You can use tools like Squoosh, free and awesome, Tiny PNG, or a CLI like ImageMin if you're automating your build. For example, if you're using Node.js, you can compress images like this. Your images are now 70 to 80% smaller, and your users will thank you.
Now, let's talk about formats, because not all files are created equal. Got animations on your site? Ditch those heavy MP4 or GIF files and switch to Lottie. It's vector-based, infinitely scalable, and way lighter.
This GIF or MP4 weighs over 2 megabytes, and your users download it every time they visit.
Now look at this, the exact same animation, but as a 60 KB Lottie file. Vector-based, infinitely scalable, and buttery smooth.
And here's the beauty of Lottie. It's just a JSON file. That's right, this tiny file doesn't contain frames or bulky video data. Instead, it describes the animation logic, shapes, paths, timing, and transforms.
Your browser reads this JSON and renders the animation dynamically as SVG. That means no huge 2 megabyte video to download every time. It's lightweight, fast, and still looks exactly like the original.
Just a few lines of code. That's all you need to replace a heavy MP4 or GIF. The animation works instantly, scales perfectly on any device, and saves your users a ton of bandwidth.
Same rule goes for fonts. Always use WOFF2. It's smaller, faster, and supported basically everywhere.
That font display swap makes sure text shows up immediately, even before the font is fully loaded. No invisible text, no layout jank, just clean rendering.
Now let's talk about lazy loading, one of my absolute favorites. The idea is simple. Don't load content until the user actually needs it. That applies to images, videos, or even components in frameworks like React or Vue. Only load them when they come into view.
In plain HTML, it's dead simple. You just need to add the loading lazy attribute to your IMG tag. That's it.
Modern browsers handle the rest. The image won't load until it's close to entering the viewport, saving bandwidth and speeding up your page load.
If you want a bit more flair, you can combine it with CSS transitions or placeholders. But for most cases, this one attribute is all you need. So far, we've already made a massive difference. Switched to WebP and compressed everything, moved to lightweight formats like Lottie and WOF2, and implemented lazy loading for images. That's easily a 30 to 50% improvement in your site's performance, and we've barely touched JavaScript yet. In the next section, we'll start cleaning up your code, removing unused JS, optimizing loops, and learning how to make your scripts run smarter, not harder. So if you're ready to make your site feel like a native app, keep watching.
All right, let's get to JavaScript. First rule of performance is don't ship code you're not using. Every unused function, variable, or file adds weight to your bundle. Lucky for us, there's a tool called Knip that finds dead code in your project.
To get started with Knip, all you need is a simple config file. It doesn't have to be complicated. Just tell Knip where your source files live, and it will know what to scan.
Then, when you run the Knip command in your terminal, it goes through your project and finds all the files and code that aren't used anywhere. That means you can safely remove the dead weight and make your bundle leaner and faster.
Loops can be sneaky performance killers, especially if you do unnecessary operations inside them. Take this classic mistake. Every comparison creates a new date object, expensive if you have thousands of items. Better way, pre-process the dates before sorting.
Wow! Same result, but now the sort is way faster.
Here's another common trap, running multiple loops over the same array. 2 loops for the same data. For small arrays, no big deal. But for 10,000 plus elements, that's wasted CPU cycles. But it's better to do it this way. 1 loop handles everything, faster and cleaner under heavy load.
Loops aren't just for arrays. Objects can be expensive too. And when you have thousands of properties, the way you iterate can make a big difference. Let's say we have an object with 10,000 keys. Now, a lot of developers do this. It works, but under the hood, object.values creates a temporary array of all the values. Then .map loops over that array again. So you're doing twice the work and allocating extra memory. A better way is to iterate directly. The for-n loop goes straight through the object's properties without creating intermediate structures. That means less memory usage and faster execution, especially when your object has thousands of entries. It's a simple trick, but on large objects, it can give a noticeable performance boost.
If you have events firing constantly, like resize, scroll, or input, they can destroy performance. Here's a simple example. When you resize the window, the normal one fires hundreds of times per second. The throttled one runs at most once per second, no matter how often the event fires. And the debounce one only runs after you stop resizing. Both techniques reduce unnecessary function calls, save CPU cycles, and make your site feel smoother and faster.
Okay, let's talk about one of the coolest performance tricks, virtualization. If you've ever rendered a massive list, say 1,000 or even 10,000 elements, your browser dies. Scrolling becomes laggy, your CPU spikes, and everything feels sluggish. But here's the trick. You don't actually need to render everything at once. Instead, just render the items that are currently visible on screen and swap them out as the user scrolls. That's called virtualization. Let me show you what I mean.
On the left, we've got a regular list, 1,000 items, every single one rendered in the DOM. It looks totally fine here, but keep in mind, on less powerful devices, rendering this much content can cause noticeable slowdowns. Every item takes memory, layout, and paint time. It all adds up.
Now on the right, this one's a virtualized list. But here's the crazy part. It looks like 10,000 items, and yet only around 30 DOM nodes are actually rendered at any given moment. As you scroll, old items get recycled and repositioned dynamically.
The browser never struggles because it's only dealing with what's visible. Smooth and lightweight. And here's the cool part. This whole demo runs on pure JavaScript. No React, no frameworks, no magic. Just a simple logic. Detect scroll position, calculate which items are visible, move and update a small pool of elements. That's it. Of course, in real projects, you'd use a dedicated library like React Virtualized, React Window, View Virtual Scroll List, or TanStack Virtual. They handle all the tricky parts for you. But this demo shows exactly how it works under the hood. Simple, efficient, fast.
All right, let's finish strong with network optimization. When sending data between your backend and front end, every byte counts. If you're sending massive JSON objects with hundreds of fields you don't even use, that's wasted bandwidth. Instead, try something like MessagePack. It's a binary format that stores the same data as JSON, but way smaller. Here, I've got an example. On the left, you see our normal JSON payload, and on the right, the same data encoded with MessagePack. And look, the MessagePack version is 26% smaller. Exact same data, less to download, faster to parse. It works both in Node.js and the browser, and the code is super simple. It's just 2 lines of code. The rest of the code is for the demo. Wow, that's all it takes. So next time you're optimizing APIs, think beyond JSON. Smaller payloads mean faster apps and happier users.
All right, that's a wrap. We covered some of the easiest ways to make your site faster, from image optimization and lazy loading to cleaning up code and cutting down network weight. If you want a part 2 with even cooler tips, like web workers, async to fur scripts, optimistic updates, and lazy loading components, let me know in the comments. And hey, if this helped you, drop a like, subscribe, and let's keep building faster web together.